Hello, my dears. Today we'll be talking about specific heat capacity. And every substance on Earth has a specific heat. And if you pay attention to the unit is this guy here, joules per grams degrees Celsius. Okay, so the unit itself tells you what specific heat is. Okay, joules is a unit of energy, grams is mass, and of course degrees Celsius is temperature. So specific heat is the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. So basically, it's how much energy it would require to take 1 gram of any substance and raise its temperature by 1 degree Celsius. Okay? Now, water has a pretty high specific heat. It's 4.184 joules per grams degrees Celsius. Now, the larger the specific heat of a substance, the smaller the change in temperature will be. Therefore, if we have 10 joules of energy to equal samples of every substance, glass will get the hottest and water will be the coolest. Okay, so if you look down here, glass has the lowest specific heat of these particular examples. There are many examples. Okay, so because glass has a low specific heat, it's going to have a larger change in temperature. Okay, so this is kind of one of our safety rules that we talked about in the beginning of the year. We always said cold glass looks the same as hot glass. So that means, if something that was glass, was heating up, it would feel very hot, but it wouldn't look hot, With water, you need to put in a lot of energy to heat up water. Okay, so, if you put a pan of water on the stove, you'll notice it does take a while for it to heat up and to start boiling. Remember, like we talked about with our heating curve video, with the heating curve, it has to overcome kinetic energy and potential energy to not only get those molecules moving, but to get them to separate from each other. So that really helps us understand, the amount of heat lost is equal to the amount of heat gained. Okay, but that doesn't necessarily mean that the change in temperature is the same for the amount of heat lost or gained. Okay, remember, we're looking at energy, so joules. Now, specific heat is helpful because it essentially acts as a constant. All of the specific heats have pretty much been determined for a lot of different substances. There is a reference book called Sigma Aldrich, and basically it has pretty much every chemical known to man, and the specific heat was determined for almost all of these substances. So this is kind of a constant. We kind of treat it as a constant. It's something that you're going to be given in most equations. And what I'm going to focus on right now is these specific heat calculations. Sometimes it's called a calorimetry equation. So calorimetry, a calorie is a unit of heat. So calorimetry is measuring heat. So it's called Q equals MC times delta T. A lot of people abbreviate it Q equals MCAT, just because this delta symbol kind of looks like an A. It pretty much stuck. I heard it when I was in high school. I also heard it when I was in college. So, whatever helps students remember it, Q equals MC times delta T, or you guys can also call it Q equals MCAT. So Q is, very simply put, heat. Okay, we are measuring how much heat is part of this reaction. So it's going to be in the unit of joules. M is the M you've known all along. It's mass. And the unit for mass, of course, is grams, not kilograms in this case, but just grams. Specific heat we just talked about, the unit is joules per grams degrees Celsius. And I want to point something out here. The fact that specific heat's unit is joules per grams degrees Celsius, when you look at all of these units, okay, once I multiply by temperature, which is degrees C, let's say that's over 1, and then times grams, let's say grams over 1, okay, this is going to equal joules because, look, these units are going to cancel out and you're going to get left with joules, which is energy. So grams are going to cancel, degrees Celsius will cancel, and look at that, you're left with joules. So these units make sense, and it works out ultimately in the long run when you want to determine what Q is. Okay? Another thing that helps students with this equation is this triangle here. So basically how to use the triangle is if you're solving for something, you just cover it up, and then the triangle tells you what to do. So for example, if I want to find mass, well, I'm going to do Q divided by specific heat times the change in temperature. Okay? Algebraically, we can keep going. If I want to find a specific heat, just cover up specific heat, and C is going to be Q divided by, this line here means divided by, mass times delta T, change in temperature. Okay, same thing any way you want to solve it. If you're looking for change in temperature, okay, change in temperature, you're going to cover up the temperature. So the change in temperature is going to be Q divided by mass times specific heat. The triangle just helps you with the algebra if you know how to manipulate an equation, which at this point you should. Basically, whatever you're solving for, you just isolate to one side, and then you pretty much plug and chug. Okay, so I'm going to do the first example with you. Again, you're just identifying all your variables and then determining what you need to solve for. Okay, so in the first example, it says how much heat, in this case it's Q, is required to heat 2,000 grams of water. So we know our substance. Okay, because we know our substance, we're going to look back on that specific heat table that's in your notes on page 7. Page 7 has all of these known specific heat values. I know that the specific heat for water is 4.184 joules per grams degrees Celsius. So that is my specific heat. Also, I know my mass that was given to me. Okay, so my mass is given. My specific heat is something we looked up. The temperature change was from 25 degrees Celsius to 100. So our temperature change is 75 degrees Celsius. So that's delta T. So we're looking for Q. And in this case, we're going to use our formula. Q is equal to MCAT, MC, times delta T. Okay, mass is 2,000. The specific heat of water is 4.184. And our temperature change is 75 degrees Celsius. And when you multiply that, you get our answer of 62,760 joules. That is a lot of energy, which makes sense because we're talking about 2,000 grams of water, and water already has a very high specific heat. There is a lot of energy required to raise the temperature of 1 gram of water by 1 degree Celsius. So this would be just you using this equation, Q equals MC delta T. For the next example, we are looking for mass. Okay, so if our formula is Q equals MC times delta T, and I'm looking for mass, I'm going to have to divide specific heat times the change in temperature to each side. and that's gonna help me solve for mass. Okay? So per the equation, or per the problem rather, I know the specific heat of concrete. Okay, that's given to me. We want to know how much concrete in grams, so I'm looking for mass. Would absorb 5,000 joules of heat, raising the temperature from 19 degrees Celsius to 26 degrees Celsius. Okay, well, to determine the change in temperature, you got to do 26 minus 19, which is 7. Okay, so I have my change in temperature, I have my Q, that's given, I have my specific heat is also given, so it's basically plug and chug. So we're going to do 5,000 over 0.88 times 7, okay, and that gives me my answer is 811.69 grams of concrete. The last example is as follows. In this case, we're looking for the change in temperature. They tell us our mass. They tell us how much heat was lost. And they give us the specific heat of gold. So I know my substance and its specific heat. So if I want to find delta T, we're just going to manipulate the Q equals MCAT formula. We're going to get T by itself by dividing by mass and specific heat. Okay, and then this is our Q, this is our mass, and this is our specific heat. So again, just plugging it all in and solving. Our delta T, our change in temperature, is 9.85 degrees Celsius. Okay guys, I will see you the next time.